Cool. All right. Thanks everybody for joining. So has everybody read the doc, or should we have a quick background? All right. No answer to each. I'll give a quick background. So I was asked to write up a database strategy, MR for the handbook, to talk about what our database strategy is, whether or not we allow multiple databases, what that means. And I'll dig up the MR here shortly so we can share the screen. And it came from an issue where they were discussing bringing in a different database technology, and then that they actually focused back on PostgreSQL. So that was no longer a concern, bringing in a NoSQL or some other technology. But then the concern was, should this live in its own database or not? And there was support for having a separate database, but then there was concerns that it goes against our single data store strategy that we have written down. And this is the MR. And what the disagreement came with whether or not we actually have just a single database or whether we support multiple databases on the same cluster. And we do have some naming clashing. We'll get to that here in a second on the doc. So ultimately what the question was, and it was raised by Sid, was if we are pursuing database sharding, then shouldn't we have everything on the same database? So all tables on the same database, not separate databases. And if we're not going to pursue database sharding, if we're going to move over to application sharding, and we still need to get common ground on the definition of what application sharding means, then we could consider having multiple databases. So at a super high level, does everybody understand what we're talking about as far as the differences here? Okay, I haven't heard any dissenting opinions. So tried to put in quick definitions of each, and then Andreas added the service extraction, and actually I added an example that's being discussed right now with the CI/CD daemon. So that was very timely, all these conversations. So the goal here is to brainstorm, list all the pros and cons of each approach, and then come together with what, it doesn't have to happen today, but it needs to happen fairly quickly, come together with an approach, what we're going to go forward with. Right now, the approach is we are sharding at the database level, and everything should be on the same database since we are already down that path. If we need to switch to a different strategy, then let's all decide together and move forward with it. So any questions, or you want to jump right into conversations about the implications and the pros and cons of each approach? All right.
Would you say we're not doing both? Or I mean, I think you might have just been talking about database versus application sharding at the time. Is that correct?
Mm-hmm. Yeah.
Okay, because service extraction is a new thing. So the question, we may actually do service extraction in addition to database and application sharding. Is that correct?
It's certainly something we should discuss, right? Because there could be, the concern that was raised is if we are taking two approaches, like we do, we'll go with this example, if we do service extraction, what does that look like? And does it cause a performance, or I'm sorry, a support matrix nightmare where we have a major database that we've sharded across, dozens, if not hundreds of shards, and then we're starting to extract services out? And does that mean as we're extracting the services out, then they're all living on their own databases as well? So we have a main database that's sharded, and then we have a bunch of other databases that are now extracted and running on their own. And how does that impact customers, right? .com, we manage kind of our own world, but what does that mean to our self-managed customers?
Right. I mean, I can argue that, like, for example, Gitaly, we did this with Gitaly already. So it already happened. It's just, we need to figure out, like, what's our strategy for the rest of GitLab.
Another example, which is different but also similar, is with Redis. We have on GitLab.com, we've got 3 different Redis clusters, going to be 4 at some stage. But then on self-managed, it all just goes into the same Redis cluster. And so it's fairly easy to manage because, in some places they're all happen to be on the same server, and in other places we can split it apart by service, right? So that's a service extraction. We've got the Sidekick service, we've got the the main persistence service and the cache service, and then for small instances they're just all together.
We would have the same benefit from having multiple databases, logical ones. We could have them. We could run them on the same cluster if customers want to do that. That's probably the easiest. And for GitLab, we may decide to run some databases on a different cluster. That makes sense.
Yeah. Yeah, and as you know, obviously you wouldn't be able to join between them still, but they might still be running together. Another example, which is pretty much the same as Stan's example, but Praefect, as far as I understand, has got its own SQL database as well.
Right.
Praefect
So,
being the thing in front.
That's correct.
Yeah.
and that was an example that was brought up too, that yes, it's got its own database now, but it has not been released, and it should be brought back into the main database so that we can then shard it.
But there is no logical overlap between the data that Praefect has and the one that we have in the Rails database, right? So my question is, why would we bring that into the same logical database?
Use sharding for scaling is the example, is the question that was raised.
Yeah, what's the benefit? I think you're asking what's the benefit of doing that, right? I mean, it's.
Yeah, there's advantages and disadvantages, right? So, like Andreas mentioned, it's an anti-pattern, right? It's not something you would normally do, to bring all of these separate databases that have no business being together into its own, just so that we can apply sharding to it for our scaling strategy.
Isn't it also quite severe security issue that you have multiple applications managing schema, because you're kind of then assuming that every of these applications is a good citizen, properly prefix tables, and doesn't mangle with other tables, and it seems kind of risky, this approach, to me.
Yeah, this is the anti-pattern that I meant. I think every application should really be an owner of its database schema. And if as soon as we have more than one application sharing the same schema, it sort of breaks everything, or breaks those abstractions. And it's really hard to manage the schema when you have one application owning the schema and then multiple other applications being dependent on this schema. That really is a terrible place to be in, I think.
I think this came out of the container registry, right, discussion. A lot of this discussion is well, container registry uses all the projects. Is why can't we just stuff, our existing database with all the tables the container registry is going to need, right?
Mm-hmm.
And it does seem there might be some benefits, because container registry does need to use all the projects, but there's so much data and there are so many connections that it would. The reason why I didn't think it was a good idea to combine them is because our load on the existing database is already very high. The container registry has been a very nice isolated service that hasn't been affected by, our database going down as much as other things. So, and our database internally, is already pretty loaded with a number of connections. Right, we're limited by number of connections we can have on the database, and having PG Bouncer in front of that helps. Yeah. But then once you start adding more applications, it gets harder to scale that. Right, eventually we're already running out of connections to the database.
So I'm gonna add to that, the problem of managing data. In our database for the arrays, we kind of we actually now enforce that there is foreign key for every relation to ensure data consistency. What now happens if we start to tie a container registry tags with the projects, and trace removes project and cascade removes all data that is managed by the container registry. We kind of have two brains controlling the removal of the data and sharing the same schema. Database enforces consistency, but who actually removes the baking data? It's kind of become probably very gray and tricky area to actually implement it properly without side effects. Because now, let's say we start hooking to project ID, container registry tags hooks to project ID, GitLab Race manages project table. You remove entry from the project table, and you're gonna have cascade deletion of the container registry tags. So normally it would be the container registry removing data, but is it not longer true? You would actually have to re-implement a bulk of the logic into Race as part of the project deletion in order to properly delete this data. Now that you would actually, today, you would call the API to actually do that for you. So it's kind of, I think it becomes like quite spaghetti, because like this consistency becomes, it's enforced on the database level, but application level, if you have multiple applications actually managing life cycle of the data, it's become kind of, I think, gray area.
Yeah, sort of to your point, Camille, there's we're getting to the size where this complexity is becoming like a thing, and like the number of people that can kind of fully understand all of these connections is diminishingly small. And like one of the things that you start having to use to tackle this complexity is replaceability of systems. And if you have like a module like the container service, which is quite a replaceable module, but then underneath it, you're just kind of using the same database, then there's always the temptation for people, like you say, to join across or run queries against other people's data. And then as soon as you start doing that, you lose the replaceability. So we can never pull a component out. Like replaceability to me is like the reason why you do things modularity, whatever, in modules, because you can pull them out and say, actually now this is no longer fit for purpose, and replace them at a later stage. And if you're doing this with like your entire database is kind of monged together, you can never replace those components. And so, if you have an isolated component, it should really have an isolated database, isolated in some way, maybe running on the same server, but not tangled up at the
probably really like logical database. Really could be like the same instance, it could be different instances, but this is then like really a matter of the configuration for the application. Like if you see that like the single instance cannot like handle the load, you move data away to separate instance, probably something of that sort.
Yeah,
I would argue that
well-defined APIs. Sorry, Andreas.
Yeah, exactly that. And on the opposite side, I would argue that if there's any reason to put the data models in the same database for two applications, why don't we have just one application implementing that? Right? You could even go that far and say, like, if container registry and Rails need to share a data model for some reason, and we need to put that in the same database, perhaps the container registry should actually live in the Rails application and not be outside of that. I don't think that's a good approach. But I think we should separate them. There is no reason to put them in the same.
Yeah, what very often, like coming from a finance background, you have these huge organizations and everyone has a different view of the data. What you often find is that you will have the same entity with the same ID, but two databases with different data in it. So the risk department, might have risk data on that ID, and so you don't have one entity that has all the data, because it's just too much and everyone's trying to change everything, but you use identifiers that are common, and then the data is different for different views. Yeah.
So Andreas, I think going back like to your point, like from like what I see how we develop at GitLab, what would happen, it would basically start re-implementing a major aspects of the registry into Rails because of that limitation. This would be the outcome really of if you would go with that approach that like we share the same schema, because this would be the only way probably to solve this kind of problem, and it would really start to occur pretty quickly. At least this is my perspective on that.
Yeah, and it kind of feels like if we put everything into the same database, then we basically bet on the idea that we can really scale this database nicely, and that that database sharding solution where you have you don't touch the application. You find a way to scale up the database, and that works for everything. And I think that's a really huge bet and pretty risky as well.
Just going back to the Redis example, one of the things that's really advantageous for us on GitLab.com is that because we've split it out and those workloads are all slightly different, we have different tuning on those different Redis instances, right? And that can help you get more performance. Whereas if you have one big general database, you always have to tune for all the different workloads. Whereas if we were breaking it down, you know, we could say there was one that was diffs or something like that. We could tune it for that kind of big blob kind of workload, for example. I don't know, I'm making things up here, but you know what I mean.
Okay. So it's pretty clear. There's some major concerns about having everything in the same database, right? So I guess what would the alternative be? So maybe we come together on what it means to shard at the application level. And if we need a different term, that's fine. We've just been loosely using application sharding. Some of the examples we've used are the Shopify pods example. Actually not, that's pretty much the only example we've been using. So does everybody have a common understanding of what application sharding means? Yeah. So what would be some of the pros or cons there?
I mean, the big thing for me with that is like all the good examples of where I see that working, it's very much isolated where we've got, you know, we don't have like we can't take a database per namespace or anything like that because the users are shared. A lot of the data is shared and a lot of the state is shared, right? And so it just doesn't feel, maybe I don't understand the methodology well enough, but it doesn't feel like a natural fit. Like for Shopify, it's a really good fit because a shop is very isolated and the models aren't shared between multiple shops, presumably. So it feels like, you know, and every shop has got a different domain and it's very easy to kind of track down that route. And there's lots of other examples, you know, lots of SaaS companies that are like that.
Mm-hmm.
Right. I mean, the flip side is that if we wanted to support organizations, right? Like let's say we had tier 1 organization we really wanted to isolate and they had their own instance, this would be beneficial, right? Because yes, there's no sharing, but they don't want to share, for example, and things that happen on their system should just only stay within their system. So, but obviously for like the, you know, public projects and things like that, it doesn't really work. But there is a use case for it if we wanted to go this route, right? Like, you know, our major customers right now would actually like that, right? They have their own sandbox.
So, I mean, this is possibly going way out of the scope of this discussion, Stan, but one option with that, right, is if we had, and this is a bit wavy hand, but if we had like a really good Kubernetes operator for GitLab, for example, we could spin up like whole GitLab instances for these customers using the same code. You know, we don't have to worry about the petitioning, you know, the application level petitioning, and they would literally have their own sort of Postgres inside that pod and that we would run for them. It sounds a little bit like, what was the hosted GitLab thing that we used to have before, but like really well run.
GitHost, yeah, GitHost.
Yeah,
right?
GitHost, yeah, but really well run and kind of with good scaling and, you know, not just what GitHost was, but yeah, that's a different discussion for a different day, right? But what I'm saying there is you could do that with multiple Postgreses. So.
I actually added to that because it's not very clear what does application sharding mean, because you could consider sharding on 2 dimensions, really like where you separate data, I mean across like the service. Let's say we have the packages service, it runs in the separate database, really logical database. It has its own API, but also there is also a point of sharding by customer. Like we move some enterprise customer to completely separate database. It has its own separate typically, and this is a completely different beast in terms of application sharding that should be evaluated completely separately. because sharding by service gives you this ability that you can, in the future, kind of move that data into completely separate microservice that is like described below, which is like service extraction, because you own that data, you own that structure, so you can move that data with the like our application code to rewrite that in something more efficient. Where sharding by customer is probably more like the, I'm assuming, Slack model. You create a team, you'd probably get your own database, your own space where you work in. And probably sharding by customer is more like creating GitLab federation. It's much closer in that respect.
What we've been discussing also with partitioning is doing this group sharding, so sharding by the namespace that you're in. And in this case, I think there are a lot of features in GitLab that only operate in this namespace, right? If you think about CI, merge request issues, most of those features, they're inside a namespace. And perhaps there's a way for us to wrap that into a service, and then we can think about sharding that on the database level by customer, for example. And there are other services or other features that are sort of cross-cutting with that. And perhaps there is an opportunity for those to extract them into a separate service. So we would break that up by looking at features and figuring out which ones are naturally inside a namespace and which ones are basically cross-cutting. And we would treat them differently. Would that make sense?
Yeah, the one sort of thing I haven't thought about this very much, but like if you have a trace coming in, it goes to like API v4 projects, some ID, you know, something, and then you still need to look, you know, all of our endpoints are not really designed with this namespace, obviously other than the web, but the API really isn't really designed with this namespace approach. And so do you have like a lookup table that then kind of redirects you to the namespace, like from the ID, or? You know, yeah, we haven't specifically our API is not designed with this API approach, and so you have to do lookups a lot, I would imagine.
So Andrew, like you mentioned trace, like probably like a lot of our endpoints are scoped by the project ID, and like if you look at our tables, a lot of the tables, they even duplicate project ID column, even it's not like a direct relation to the project ID, but like if we talk about the CI build and trace, it's actually looking up specifically by the given build ID or like by the given project ID. But the lookup table, we actually have roots table, which is our lookup table to figure out how to transition from the path, I mean full path, to the given scope, which is namespace or project. So in that model, like the roots table would probably be stored somewhere else in a central piece. But then like if you do partition by project ID, a lot of the tables are already prepared to the partition by the project ID, basically, because they have the project ID in their column set.
Right. So are you saying that it would be fairly easy to do that lookup then to map to like a application partition on the project ID, Camille?
Yes, because like we have roots table that translates a full path into like the entity, which could be namespace, project, or container registry path or whatever else. And like we actually use that. We started using that once we introduced the subgroups, because this was like the only efficient way to do this transition. And I believe that we also use, I may be wrong, but I think that we also use roots to figure out exactly subgroups for a given group.
Right.
So like what I'm saying, like we really have already like central roots table, which is like central to perform routing.
So it would be fairly easy to always make sure, like almost like a middleware, when you come in, it just maps that out and then sets the context.
It's probably even more interesting because roots table it's not, I don't think that the root table is pretty big, but it doesn't change very often as well. So you could be slightly inefficient and replicate it on all replicas to make root table very close to the data that you are looking at. And it still would be fairly accurate. I don't know if Postgres allows that, but this is like the possibility, really, that like you keep root table like replicated multiple times, assuming that this is like pretty stable and like you do not create a central contention point where you have to go through roots like in the central point.
Or you do service extraction on the root service and just have a single one. But yeah.
There is multiple ways to catch that.
Yeah.
Why are we saying that application sharding doesn't work for public projects?
Oh, the idea is that every project that's in its own database would be really hard to do this cross database join, right? The idea is that you would just basically have your own sandbox, and you would just query against that sandbox.
Okay,
but we're talking about things like Explore.
Yeah, or or any project for that matter, right? Yeah.
Yeah.
I think one of the things we discussed there was you'd almost have to have some kind of like maybe at the database or some other storage mechanism to share those cross database or cross project, whatever cross join. You'd almost have to have like a coordinator database or coordinator application that aggregates all those together if we want to continue to support those like public searches across all the different pods.
And that presumably would also have the users in it, right?
Yeah, yeah. So it's almost, it would be similar to the database sharding, at least the way I understand it, how Citus described it, where you'd have the some kind of data replication somehow. So, and I have to leave in about 15 minutes. So what I need to come up with is database strategy, and all of this feeds into it. And I need to answer the concerns about what our next steps are. And if we don't have an answer today, that's fine. I can buy us some more time. There's a lot of information here. But the big concerns still are the support matrix and how does this go again? If we're going to go away from a single database, which it seems like we are, and everybody's in support of that, how does this goes against our single app and our single data store message? Do we need to change that? How does this impact our self-managed folks? Do we need to diverge so that what we're doing for .com doesn't necessarily ship with self-managed? What's our strategy for scalability and availability going forward? We already know that our database is a major concern, and we've heard somewhere between a year and 2 years it's going to hit a wall, is the example that was used. So we need to figure out if we're not going to pursue sharding because we don't want to have everything on one database, or if we are going to pursue sharding but we're going to allow separate databases, what is the impact, and how do we sell that? How do we convince everyone that this is the right strategy? And I think having everyone here and having detailing a good strategy going forward, people will support it. But that's what I need to explain in the coming days.
I think you really want to make it clear from the outset that it's never going to be like forked GitLab or anything like that. Like, I don't think that's a strategy we ever want to go down, where we have sort of two different versions. And we want to make that like clear from the outset that that's, not the approach that we'd want to take.
Yep.
So if we only allow using multiple logical databases, they could still live on the same host in Omnibus. So we would still ship a Postgres that has like a couple of databases installed, logical ones in the same cluster. So in terms of management for self-hosted installations, that wouldn't make any difference compared to if we stock all the data in the same database, right? We would still have one cluster. We would still have all the data on the same cluster. So that's not really a difference, is it?
Can I just ask a question? If people are using cloud database services, they're self-managed, but cloud, do you get a whole Postgres server or do you get a database? And so would they need to have 5 or 6 databases in a cloud managed install at 5 or 6 times the price?
I believe you get a whole server. It's just
you get the whole server. Okay.
Yeah, you can basically create database within that server. So
okay,
whether it's RDS or Cloud SQL.
Yeah, okay, cool. Then that's like a non-issue. Just wanted to check.
So it means that like supporting logical databases would be possible, but then there is like it's probably troublesome to set up, let's say, replication of that in somehow semi-automated way, because if you would follow that model, you would assume that we're gonna add more of these individual databases, and there has to be some automation behind allowing this to be automatically supported.
So if you talk about replication in Postgres, we talk about physical replication typically, and that means replicating a whole cluster. So whatever database you add, you don't really care there for replication because it just replicates the whole cluster. So in that sense, there's nothing we need to do with respect to physical replication for that.
Cool. So technically, this is not really like a problem if you would have to support multiple logical databases.
Right. I think the only concern was the Praefect was Praefect was discussing this, and they actually said we don't want to replicate all the things in this Praefect database. And I said, well, it doesn't actually cause that much harm. It just, you just generate more load and data on the secondary because you're replicating stuff that the secondary doesn't really need. But yeah, you can just create a new database and you'll get it for free with Geo and Postgres. So.
And the beauty from that is that if we ever realize that we don't want to be replicating everything, we could go ahead and just extract the database, put it on a different cluster for GitLab Conf.
Right.
That makes more sense for us.
That's correct.
With the Praefect, sorry, Stan, with the Praefect example though, I thought that the geo secondary still needed a write database because the Praefect would, so it wasn't actually that it was replicating off the primary, it was that it needed to be writing from there. But I don't know if that's a...
Well, no, so Geo has 2 databases, right? It's replicating everything in the primary. So everything you put in there is read-only, but then it has a second database that it writes to. So we already do, in the Geo model, we're already using 2 completely different databases right now.
Okay, yeah, then that makes sense, yeah. Okay, thanks.
I think that the question is really about like within the application, do we actually like allow application sharding? I mean, in any model, or we don't allow? Because then does it actually like it's beneficial to do application level sharding? Or is it like you kind of figure out architecturally how you should create like a new tables to make them possibly shardable via Postgres methods in the future if it needs to, if we start adding new databases and we start adding new tables. Sorry, it's a little chaotic, but like my question is really like, we have different approaches to application sharding. It's by customer, it's maybe by service. By service allow us to do service extraction later. But if we like keep things as is today, which is like we have GitLab Trace, which is like big application that adds into its own database and everyone adds into that database. It's very likely that we're gonna have to shard this database anyway at some point in the future. It's kind of inevitable. So then my question is like, how we approach this sharding in that case, and in future cases, if we allow to create logical databases to make this data structure to be actually shardable via Postgres methods if we need that.
So let me see if I understand. You're saying that even if we were able to do application sharding, application sharding, you still think database sharding would come in at some point in time?
Yeah.
Okay. Yes.
So,
I would assume that at some point we'll probably have to do application sharding.
It's kind of like what's happened sort of more naturally with Redis is, we split it off into these different service extractions, and now we're looking at taking the cache one and switching that over to Redis cluster. Because we still need more, we've got as much capacity as we can out of this strategy, and now we're going to the next strategy. But the question or the sort of comment I wanted to make was that if you have that service level extraction, surely database sharding is easier because the scope is more limited, because you have this shard and it's not like across everything.
Yep. Okay, I added another section in here about logical databases. Seems like the best title for it. So, which is effectively the path that we're on right now. So having Praefect in its own database, Gitly in its own database, and container registry wanting to be in its own database. It seems like that's the way folks are leaning right now. If they take a quick poll, is that the preferred path at the moment for folks on this call?
So it would be a logical database in self-managed, but it would be something that we could pull out on GitLab.com if we had scaling issues. So is it different from service extraction, or is it just the same thing and that's the implementation detail, is that it's a logical database?
I would say it's kind of the basis for service extraction. So you're allowed to extract a service and it can talk to a logical database that it owns.
All right, move down to service extraction then.
So probably like for services, we would assume that each service has its own database, basically. It has its own logical database. This would be probably like the design. So like its own credentials, its own permissions, its own schema that fully controls. Then the question is like, what are the guidelines for this schema if we want to shard these data? Let's say container registry gonna scale fine for another 1 year, but maybe in 2 years, the database gonna be too large and we're gonna have to shard this database. How this schema should be done today to allow us this sharding, if we control that decision now.
Yeah, so then we could potentially, for each service, have a separate sharding strategy. And that's one of the concerns, right? Do we start having the support matrix? It's just unmanageable for our .com instance and for our self-managed folks.
Greg, can I ask though, would it ever be, is there a need, or Stan's probably the best person to answer this. Do customers have this need to shard, or would it just be that the only setup that we support for customers, so from a support point of view, is logical databases? And if they want to go beyond that, it's really, they're kind of going off piste and doing it themselves. But we don't support database sharding for customers, only for GitLab.com.
Well, I don't know of any customer that needs to shard right now. Like no customer is near what GitLab.com is doing. I think the concern is that eventually one or some of them may do that. But yeah, there's no one even close right now.
Right.
But really from a sort of like a support matrix concern point of view, it's probably, maybe we shouldn't tie that into this. We can just say from a support matrix point of view, for now at least, the only option that customers have is non-sharded. So we're not going to kind of complicate the landscape with like different, database sharding options as well as everything else. Does that make sense, Craig?
Mm-hmm.
Yes, actually, it gives you another benefit that for our customers, they can move logical databases into different instances, and it kind of unlocks a lot of computing power and database on its own. So I don't know if we're ever gonna have customer running at the scale of GitLab. That would not suffice, given the scale of our single Postgres instance today.
it gives them that option, but we sort of like from an omnibus point of view, we don't give them that option. The omnibus sort of option is logical, single PG, logical, and if they want to go beyond that, they can kind of do that. And you know, we've got customers that we know will probably do that, but maybe it's not supported.
Okay. So it sounds like the service extraction is the preferred path at the moment. And we still need to look into sharding the main Rails application, but we don't want to add other databases, other contents of other databases into that simply because we want to have a single data store. So how do we, and I got to run, but how do we answer that single data store? Or do we just need to change the wording on that?
Well, I don't know what the data store could mean. Like it could be the same database instance, but just, you know, data lives in different, you know, actual logical databases, right?
Yeah, and that was a question I asked, and the answer I got from Sid was assume a single database is what we mean by a single data store.
But I think that term is really overloaded. Like we really have to be clear what we mean by database. And
Yep. Yeah. And I tried to clarify too, and he kept going back to assume a single database.
Yeah, but perhaps we're talking already about the same thing.
A single database type being Postgres.
No, single database with all tables in that one database.
So probably it doesn't really matter as long as Andreas what he's saying, like we can easily and automatically replicate all data for the whole instance. So then like this like, logical thing is like it's supplementary, it gives you better separation, but like you don't really have any major downsides there.
Well, and the other concern that was brought up was the distribution piece, right? If we start allowing databases to be created, then distribution has to be concerned about setting up the database, setting up the connection, managing all those things on self-managed and in production. So
I think we've got a fairly good, I think the second one we have a fairly good answer, which is, you know, they're all just logical databases as far as omnibus and self-managed and support is concerned. And so I don't think that there's a huge amount of complexity on that second one. I just want to, this is a slightly cheeky question, but where is this database strategy? When was it written? Because it's sounding a little bit like dogma, and we all know that GitLab doesn't do dogma. So, you know, obviously strategies work at different times in an organization, and here it is, single data store.
It's linked in the doc above, and I have no problem pushing back saying, you know, we need to change our definition of data store from single database with all tables to our data store needs to be Postgres, right? Where we can have multiple logical databases. And so there are some related docs, and I will link them all to the bottom here. And then I had the same questions about what does single data store mean? So I got to run. And I will come back and read any updates to this doc, but it sounds like we're all leaning towards the service extraction and logical databases. But I'm gonna need to have follow-up conversations, and the strategy, the MR that I have written up, it does follow that same strategy, the service extraction.
So then the follow-up question is going to be about sharding those specific logical databases, right?
Just not necessarily, right? Because we're only considering sharding the main Rails database right now because it's so big, and we know we need to scale that out. But how does that complicate things for our customers is the big concern. Like the overhead with distribution, which Andrew just answered, he doesn't think it's a major concern. do we need to change our dogma for the single data store? How do we define that? How do we get everybody on board? And how do we, I guess, how do we manage? So so we don't have like 40 different databases in a month, right? How do we manage the database growth? If we're making informed decisions about creating individual databases, how do we make sure that it's not just, oh, everybody can create a database?
I think that that's something that I've been thinking about a lot. I think that's a big concern, is people just proliferating. Because that we definitely don't want.
I think that was
ask a question.
I gotta run.
Yeah. So when we say logical databases under the same data store, do we mean that they will have we're going to connect to them using the same address and same port? So we assume from the get-go that they reside in the same database server.
I was imagining same PG bouncer, but different connections in PG bouncer. I forgot the.
I mean, you could have different PG bouncers too, right? Like it doesn't have to be.
Yeah. But the default would be one, right? Or with multiple pools.
Right. I mean, the beauty is you can choose, right? Like if you're self-managed host, you can just say just connect to the same database. And then we'll select which logical database. But for us, we can split it out if we need to, and I think we're going to need to.
Stan, could we? This is a bit of a silly, like a bit of a crazy idea, but could we have multiple PG bouncer pools that actually behind the scenes connect to the same database, and so you have the same tables in the same database, but with no connections between them? Do you follow?
Sorry, say that again. That was
so you almost have, imagine you had, like, if you wanted a single data store. I mean, this is kind of just hacking terminology, but if you say you had a bunch of container tables, you actually keep them in the same database and for self-managed in literally the same logical database, but we just keep them apart, and then we go through a different PG bouncer pool, but it actually targets the same logical database. I don't know. No, it's
a little scary, idea. But I mean, that's like you might want to have different user permissions on tables. That's kind of a nightmare, but you could go something crazy like that.
Yeah, but Andrew, it's just better to have logical databases.
Andrew, we could create logical databases with plenty of the views that would use the same database. You would have your own perspective on the data.
Exactly.
Access. And like, you can really insert and update these entries. It's gonna work fine.
Yeah, but I think logical databases seems like a reasonable kind of approach.
I mean, like, the truth is, like, for the container registry, we likely not gonna have to scale this. I mean, Sharding database for like at least probably next 3-5 years. So we may need to start GitLab Race, but all these actuary databases, they're gonna be just fine with scaling them slowly, as we did with GitLab Race, because of the
What about if we had like a strategy that when people sharded off a database, the new shard had to be, the new service database had to be database shardable from the outset, so that
this is what I mentioned. If you would document from the get-go how the data structure should look like to make it shardable, if we need that, it would be likely quite useful in the future if we have to do it. Because I think, Andreas, what is facing right now with the sharding of the GitLab Race, that this data structure is only partially shardable. So it gives you like very mixed results. And this is actually a problem of sharding GitLab Race today, if I understand.
Yeah, I know like Amazon, I think someone told me Amazon doesn't allow foreign keys. They require you to use not actually an RDBMS, they actually require you to use like a NoSQL solution so that it allows you to kind of break apart these kind of things. So I'm not saying we should do that, but that's the extreme approach that they've taken, right?
There's a Jeff Bezos memo from 1996 that any cross-department access has to be API driven. You can Google it, Stan. It's
right. No, I heard about that. Yeah, but I mean that's going to be designed to be startable from the beginning. Other than you don't have to keep figuring this problem out.
And we could easily start with those services with partitioning, for example. So you would have that idea of sharding in mind when you create a new application, and from the get-go you start with partitioning along that dimension, and I think that naturally prepares your data model, because you already have to have it in that way. Later on you can decide to shard that. That makes more sense.
Yeah, that makes a lot of sense. And I think the container registry is probably the first place we want to try this experiment, because they're about to try to do something there.
Actually, there is like very good probably aspect that maybe we should move our like the data schema validation of the arrays and load balancing code, which is like very specific to us, into LabKit Ruby and LabKit Go, and basically have like the single implementation for the database manipulation and like database configuration. Because
Yeah.
you could start enforcing these decisions about the partitioning as part of the specs, and if you would have that consistent in the LabKit for Ruby and Go, it would kind of be used right away.
LabKit's scope is increasing quite a bit.
Yeah, that's quite a, yeah, I mean, it's possible, or yeah, it might be, I mean, the main thing, I wouldn't want to go in there like no, let's see, I mean, that might work. So,
I mean, creating those applications and from scratch, and then already thinking about sharding, that's an awesome way of doing that. How do we go about GitLab Rails? I mean, that's sort of the tough spot that we're in at the moment to figure out how we approach that monolith.
So what's the #1 hotspot that keeps you up at night? Like what would be the thing that if you had to pull it out and shard it, what would it be?
I don't have a really good answer to that. So I think we need to be more systematic about understanding our load. In terms of database size, we can see that CI data, for example, is really a lot. It's like a major portion of the database.
What about like traces or jobs or?
Yeah, and that's what it is, right? Those rows are growing like crazy. Even though we've offloaded a lot of the stuff, the traces themselves to S3, but you know, the number of rows increases like crazy. Like those, I think diffs are actually the biggest, but we've offloaded those to object storage as well, right?
And there are other solutions than. And there are other solutions than you know, sharding that or extracting that. Maybe we don't even have a retention strategy for CI data, and we've been discussing that. So maybe that's also a way of doing it. But in general,
I was actually talking to a customer yesterday, and they were complaining about that exact same thing.
That their CI data
about
is
the retention
growing.
strategy. Yeah, exactly.
Right,
and they run their own scripts to clean it up.
But that aside, how would we also, from an organizational perspective, like approach this? I feel like from our team's perspective, it's not possible that we find a drop-in solution for the database without touching the application really. So I think this is a much larger scope for us to tackle. So I wonder how we would even approach saying that we want to, I don't know, extract a feature from GitLab once we identified what that is.
I think you've got to start with something like the container registry, and then have it as a demo that people can like look at, or you know, and then it'll be more tangible.
So Andreas, like for the CI/BIT and sharding, I don't think that you're gonna be able to do it efficiently today. Before we change before we start doing CI daemon as a separate service that can efficiently queue bits, because there is like no partition that you could use for the CI bits table that would be efficient. That's the tricky part, because then like my natural answer would be try to partition by the project ID, but how the system works today, it's not sharding friendly at all. That's the tricky part. So it will fare miserably, at least from my perspective, until we move this all processing of the queuing into something more optimized and specific. Then, like I would then say, you just shard by project. Like we always access pipelines in scope of the given project. We don't cross projects ever. really when accessing this data. Like it happens very rarely, but like in very specific cases. But for the majority, it's like it's the project which is like the scope for the pipelines. And
is that not the case today? Because you mentioned it wouldn't work with the current database.
This is the case today, but because of the queuing, queuing doesn't care about the project. It looks at the whole system. So you need to have the perspective of the whole system. I kind of vaguely remember that you had the issue about testing different partitioning for the filtering issues. And like the problem was, from what I understand, you were crossing boundaries between different shards. At least from what I understand, the sharding to be efficient, like you don't really want to cross boundaries because then like joining this data, it's like super expensive. So because of the queuing of the CI builds, you cannot do sharding because this queuing works on the depending on the instance level, group level, or the project level. You cannot figure out the efficient partition for that. That's the tricky part. At least this is how I understand that. So in order to make CI shardable, we need to move queuing away from GitLab. Then like you could start sharding CI using project, and it would work pretty much without any application changes. It would be only Postgres change then. But today it will. I don't think it will work efficiently at all. That's the tricky part. It's gonna, I think, gonna have severe performance degradation because of the how we process queue today. This is the problem.
Mm-hmm. So
that the queue requires us to have the full view on the system, which is files with sharding. That's the tricky part.
So what you're saying is also that don't even try to like change the existing system and make that shardable, or apply partitioning to it, but extract that. Wait until we extract that part of the system and make that more scalable from the beginning. Is that what you're saying?
Yes. So what I'm saying, like sharding of the CI bit doesn't make sense today because we're gonna fail. What we can do like is move queuing into a completely separate service that is like optimized for that purpose. The current system is not optimized for that scale. And on the other hand, basically finish data retention of the CI builds. It's gonna remove a significantly working data set that we need to keep in the memory today of the CI builds, which increases the pressure on the L1, L2, L3 cache when you are going through indexes. So, so what I'm saying, like with the retention, we can buy probably another 1 to 2 years where we don't need sharding, where we're not gonna need sharding, but in the long term, we're gonna need sharding anyway, but we'll not be able to do this sharding today because of the how queuing works. Until we change queuing, we cannot really do sharding of the CI bits. That's what I'm saying.
So we're basically in a time where we would already know about the scaling problems. That we hit the wall in like 2 years or so with the current design, and we're in a good spot today to figure out what parts of the system we would extract and redesign, instead of trying to keep going in that direction without thinking about the service design better, and then trying to find just a sharding solution, a distributed database solution that allows us to keep going in that direction. So we would prepare for today we could prepare by starting to extract services from the application, making them better.
Yes, because like if you would move the queuing into separate service, you would already remove a ton of load from the database. That is happening today because of these expensive queries that some of your team mentioned. Second, like if you would have retention, you would reduce significantly working set. Probably you mentioned something that this table has something about like 200 gigabytes. So probably it would be like reduced by 3 or 4 times the data set of the table, and then like we can kind of implement sharding on majority of the CI, because it would be kind of completely detached the service. So it's kind of like random set of defaults, but probably this is the timeline that I'm seeing for sharding to be feasible for the CI.
Okay, thanks everyone. I have to run now, but this is a good discussion.
Yeah, thank you.
Thank you. Have a good day.